in some time. Sir, welcome to the program. Happy to have you yet again. And it's always a pleasure to hear you speak. Welcome. I
Thank you.
welcome I welcome Professor Ashwini Charpe to the program. I've known her as a senior in my college and as a very vibrant orator and a debater. And I have memories of that time. And I'm very happy to have you on the program, ma'am, to share your research and to discuss on the topic. Welcome to the program. I'm happy to inform yet another member of the IGNOU family, Dr. O.P. Sharma, who is also the director of the National Center for Innovations in Distance Education at IGNOU, and and we are associated for the Innovation Club activities. I'm happy that sir is able to spare time and join us on this panel discussion. Welcome to the program, sir. I also welcome other IGNOU members, members of the IGNOU family, Dr. Anil Kumar Mishra, Sandeep Gupta, my own colleagues from the regional center, Anshuman, Smriti, Subhash, Dr. Kumut, and together we extend a hearty welcome to each one on the program, extending welcome to the coordinators, counselors, and students who have joined us or who would be joining us in some time. Rajiv sir, of course, Rajiv Kohli sir, welcome to the program, sir. You have always been a very good resource person and a support for very many of our initiatives. Welcome to the program.
Thank you.
As you're all aware, today we are celebrating as the National Science Day, and this day is being celebrated, the 28th of February is being celebrated since 1986 to commemorate the discovery of the Raman effect after the famous Indian physicist Sir C.V. Raman. And he was also awarded the Nobel Prize in 1930 for his work, and later on the Bharat Ratna also. Sir C.V. Raman continues to be an inspiration to all of us, and the idea of celebrating the National Science Day is to bring about awareness in the society about the power of science and technology, and also on the importance of increasing and promoting scientific temper in the society. With these ideas in mind, we are holding this panel discussion today, and the way we have planned the program is each of our panelists, starting with Dr. C.K. Ghosh, would speak for 10 minutes each. Dr. C.K. Ghosh, followed by Professor Ashwini Charpe, and followed by Dr. O.P. Sharma. All the three of the panelists would speak for 10 minutes each, and then we open the floor for discussion, and then they can again share their ideas, views while responding to the participants. I hope that we have 30 participants already, and I believe that more people will be joining us, because a panel discussion is always very interesting, and when we have such speakers who are a pleasure to hear to, it always gets extended also. But I'll try my best to limit it to 1 hour or 1 hour 15 minutes or so that we are all timely we are able to wind up the discussion. I'll request all the participants to mute their microphones, and I'll also request the participants to keep writing in the chat box if they have any queries or any questions. If there are any questions or any comments, if it comes to your mind, please note it down in the chat box. And later on, when we have a discussion, that time you can unmute yourself and also speak directly to the panelists. So that is the way we have planned it. And so let us begin the program. And the topic for the day is scientific temper and indigenous technologies for a Viksit Bharat at 2047. That is the topic. And before we begin, I'll take a minute to introduce Dr. C.K. Ghosh, and that way we'll go ahead and before each speaker speaks, I'll introduce them briefly. So I would like to introduce Dr. C.K. Ghosh to the audience before we request him to share his views as a panelist. Dr. Chinmay Kumar Ghosh has retired from the Indira Gandhi National Open University, where he has worked in various capacities as the director of the Regional Services Division, which supports the students across the country through its regional centers, as the director of the National Center for Innovations in Distance Education, as the director of the Student Service Center, and also as the regional director of the regional centers in West Bengal and Sikkim, and also in Delhi. He has been a senior who has been very inspiring for all his juniors throughout his career and also his students. He has taught physics at the Scottish Church College, Kolkata and IGNOU. He did his PhD from the Calcutta University in thin solid films while working as a scholar of CSIR at the Indian Association for the Cultivation of Science. He has co-authored 11 books, 4 in the area of physics and at the UG level, 5 on innovations in distance learning, and 6 volumes on general knowledge. He has more than 100 publications, primarily in the area of physics and mathematics, open and distance learning, in the form of research papers, articles, edited literature in national and international levels. He has published and presented widely. He's a member. He holds membership of several professional bodies. After retirement, he continues to be very busy and takes invited lectures at various places. He's a consultant at the National Institute of Open Schooling, Center for Education and Technology of IIT Kharagpur, and is currently associated with several projects of the NCERT. Sir, it's a pleasure to have you, and we welcome you for your deliberations on the topic Scientific Temper and Indigenous Technologies towards a Viksit Bharat. Over to Dr. C.K. Ghosh.
Thank you, Dr. Toms. It's indeed a pleasure being here on the National Science Day. I take this opportunity to extend my heartfelt greetings to Dr. Winnie Toms and her entire team at the Regional Center. I extend my greetings to my fellow panelists, Professor Ashwini Cherpe and Dr. Om Prakash Sharma, my old friend. And I once again join Dr. Winnie Toms in extending my greetings to this august audience. National Science Day is definitely a very important occasion for all of us. On 28th of February 1928, the observation of C.V. Raman was finalized, and which got the shape of a famous effect, and he got Nobel Prize in the year 1930. I'll spend just 1 minute on his work. In fact, you know, the spectroscopy or the spectrum of a particular substance or a particular molecule, there is an important topic called molecular spectroscopy. So the spectrum of a particular substance is its signature. And why it got importance, that by way of an optical operation, the signature gets changed, which is called Raman scattering, and it is very much relevant even today. And I take pride in saying that C.V. Raman had did his research in the same institute from where I did my PhD, Indian Association for the Cultivation of Science. And I still feel concerned about 2 words in the name of the institution, association and cultivation. Many people across the country, and it's a reason for a little bit of anguish of mind, that by way of using the word cultivation, many of them feel that it's an agricultural research institute. I don't mind being a member of an agricultural research institute, but that it is not. It is very much on hard science. And the word association, it so happened, in fact, in IGNOU itself, I was invited by, when I was at Delhi, and I was invited by Indian Association for Cultivation of Science for a talk, and an approval for my academic leave was to be obtained from the Honorable Vice Chancellor. And the Vice Chancellor's office raised a question that how can an association be an office, a government office? The question may be legitimate, but I got little concerned about the level of knowledge we have about the activities on sciences going throughout the country. Indeed, the name association was there, which was coined by none other than Dr. Mohendralal Sarkar, a great homeopathic doctor who treated many stalwarts, which includes Ramakrishna Paramahansadev. And he had tremendous knack for science, and he thought that an association should be built. And that gave the opportunity to Sir C.V. Raman, because he used to travel through that particular street, Bowbajar Street, where the association was located, and he used to see the nameplate. And then he expressed his desire. And to cut the long story short, he joined Calcutta University again at the inspiration of Sir Ashutosh Mukherjee, the then Vice Chancellor, and at a salary which was virtually 50% of what he was drawing. And then what he did is a history, and we are all proud of that. And if you see the process of development of physics between 1900 and 1930, there is a famous book by George Gamow, 30 Years That Shook Physics. You'll find that there were many stalwarts, apart from Einstein and Max Planck. There were players like Niels Bohr, Dirac, and all. Now, the point which I want to bring home, that all of them received Nobel Prize at least 3 to 4 to 5 years after their nomination. Einstein was nominated in 1905, got it in 1921, but C.V. Raman got it within 2 years. This many of us might not be knowing. And foreign travel was not very easy at that time. In fact, when the news came, his assistants asked him, how could you manage to go to receive the Nobel Prize? So he opened the drawer and showed that already I have booked 2 tickets, one in my name and one in the name of my wife. He was so sure, so confident about the importance of his work. I just wanted to mention, though it does not directly fall on my topic. The topic is very crucial: development of scientific temper and indigenous knowledge system. In fact, both of them are linked. If not directly, they are linked indirectly. So I'll spend some time on development of scientific temper. First of all, for developing scientific temper, you need not be a scientist, you need not be a science teacher, you need not a researcher in science or a student of science. It's a way of life. Scientific temper is a way of life, that is trying to find out the causality behind things happening in and around you. Like I remember, in fact, if we take the example of Sir C.V. Raman, now scientific temper is about questioning. And like Dr. Toms was giving very much importance to the question answer session following the deliberations of the panelists. So I, at this stage, also take this opportunity to remind you that please question, because that is the manifestation of scientific temper. And C.V. Raman had questioned, why is the ocean blue? Albert Einstein had questioned that I am traveling in a vehicle and another vehicle is traveling by my side parallelly with the same speed, then that vehicle appears to be at rest. So if I go on increasing my speed and I attain the speed of light, will light become standstill? And there has been revolutionary thoughts emerging out of the probe to these questions. And it's not only the scientists. Swami Vivekananda had asked a very direct question to his guru, Ramakrishna Paramahansadev: have you seen God? In fact, he was asking this question to each and every sage whom he was meeting in his quest for God. And everywhere he was getting an answer in negative. But first time in Dakshineshwar, when he gets an answer in affirmative from Ramakrishna Paramahansadev, that comes the next question, that can you show me? So I'm not talking about any kind of religious belief or spirituality or anything related to that. I'm just requesting you to appreciate the directness of the question. So that is the manifestation of scientific temper. I had been to Shantiniketan many times, and the main attraction there is Rabindra Bhavan, the museum. And annexed with the museum is a library. And at some stage, I remember several books which were read by Tagore himself were being digitized. Now, I had the fortune of going to that Annex C library also, and I picked up one science book read by Tagore. Now, he had the habit of writing comments on every pages. And in one particular book written by one Mr. Charuchandra Bhattacharya, a famous teacher of science of that time, there was a chapter on electromagnet where Tagore has written in his own handwriting as an adolescent child that it's a very complex matter. I don't believe it unless I see it. Khub jutili bishoy na dekhle bojhar upay nehi. So that is science, that is scientific temper. I don't believe unless I see it. Galileo almost sacrificed his way of living. He was jailed. He was behind the bars just because he wanted to believe what he has seen, and that's why he is the father of observational science. So there are persons. Gandhiji never performed experiments in a chemistry or physics laboratory. His acids and alkalis were not picked up from the shelves of a chemistry laboratory, but from the life of the people, and he did his experiments with science, here with truth. So, development of scientific temper is to be inculcated by asking questions and finding a plausible reasoning with rational thinking. Like even study of history has to be investigative. People talk about rote learning in the study of history. I have discussed with students, and many of them say that they don't like history because they have to memorize a lot, they have to rote learn a lot. But history has to be learned like a historian approach a subject. You place yourself in the shoes of a historian and try to investigate what has happened, and that is the scientific approach. And more than anything else, you go to our constitution, uh, Article 51A, Clause 6, that it is the duty of every citizen to develop scientific temper, spirit of inquiry, and scientific humanism. So only when you do that, then you are developing scientific temper. And we should feel proud that it is the constitution of our country which has these lines enshrined in the document. And if we talk about indigenous knowledge, and if we look at India, in fact, again, we should feel proud that more than 42 sites as of today have been designated as heritage sites by UNESCO. There are several other things, and in this short time, well, I'm not going into those details, but I'm just talking about the temples in South India. This is one part of our heritage, not the whole of our heritage, one part of our heritage. You go to Brihadeshwar temple in Tanjavur. You go to Madurai Meenakshi temple in Tanjavur. See the architecture, see the planning, see the kind of erection that has been done with different pillars and several other accessories. So this has been done by way of indigenous knowledge. This has been done by the knowledge that existed in our country at that point of time. So if you want to probe them, this probing again links you with your scientific spirit of inquiry and the scientific temper. The entire Brihadeshwar temple is built by a granite rock, and more than 35,000 tons of granite rock has been used for building the Brihadeshwar temple. The main dome over the Sanctum Sanatorium is again a big granite rock. How it was lifted there, how it reached there. So if we can probe them in right earnest, again, that would be an exercise in inculcating scientific temper. And if we probe it in the right earnest, which unfortunately has not been done so far, we have read different kinds of history, but we have not read history with that particular outlook. So if we do that, then it would again be an exercise, a very diligent exercise in scientific inquiry. So that's how I link this to. In fact, the theme for National Science Day today, which is every time declared, and if you see the Google, it says that indigenous knowledge for Vikshit Bharat. Whereas I was reading an article, the lead article from the Hindu today, it tells about science for sustainable society. So of course they are very much linked. And that's how, if we go for acquiring the indigenous knowledge in the right earnest, then we will be serving science. And we will be able to perhaps convince the bureaucrats about the importance of science. In fact, we should also keep track of the thing that only 0.64% of GDP is being used for R&D in science, and which has come down from 0.7% in 2007-2018. So we need to judiciously explain the role of science, and it is essential that science should not be restricted within the four walls of research institutes like Indian Association for Cultivation of Science or Tata Institute of Fundamental Research. And in this era of information age, and when there is so much of social connectivity, we are answerable, the scientists are answerable to the society And the society, particularly those who are staying in the rural, remote areas, they would be more aware of the indigenous knowledge. So, with the help of indigenous knowledge, riding the vehicle of indigenous knowledge, we can bring home the fruits of science to them. And that would be another way of doing justice to scientific temper. I think I should stop here. I once again thank the organizers for giving me this opportunity, and I thank the audience for their patience. Thank you very much.
Thank you so much, Dr. Ghosh. It was wonderful to listen to you, and thanks for beginning with Dr. C.V. Raman and his effect and his research, because not many people know the details. Other than that, he got the Nobel Prize and just the topic of maybe his research. But thanks for sharing those details with us, and about confidence that about his taking his tickets for the keeping his tickets ready to receive the Nobel Prize, things like that. Really inspiring to hear these things. And of what you said, inculcating scientific temper, I like the part about the being proud that our constitution has in our constitution itself, it is mentioned that how important it is to have scientific understanding and so on. So that is really something that we as citizens need to be proud of. And definitely scientific temper it's not a small topic. It is something which is very vast, and maybe during the course of the discussion we'll be able to hear more from you when people ask questions. You were talking about R&D and how it has there is not much research as there should be. So we have another person, the next panelist, who is a hardcore researcher, and also we talked about research staying in the four walls of the research lab. So here we have a person who actually does research and then goes out to the field and to disseminate what research has taken place. So with these words, I thank Dr. Ghosh once again for a very enlightening and I call upon Dr. Ashwini. But before that, I'll take a minute to introduce her to the gathering here. Dr. Ashwini Charpe has graduated in agriculture and obtained graduation and master's degree in plant pathology from JNKV Jabalpur, and then PhD in biotechnology from Banasthali University. She has joined Dr. PDKV Akola, Maharashtra in the year 2005 as assistant professor, and continued with her teaching and research. At present, she is working at Dr. PDKV Akola, Maharashtra as professor in plant pathology, and is currently posted at the Akola Center of ICR All India Coordinated Project on Post-Harvest Technology. Her major area of research are molecular markers development, marker-aided selection, molecular host pathogen interaction, disease forecasting models, post-harvest loss assessment, post-harvest disease management, nanotechnology, and biocontrol. She has received several awards for her research work, which include the Kranti Jyoti Savitri Bai Phule National Award by the Bharatiya Krishak Samaj for contribution in agriculture in the year 2012. She has received the Adarsh Krishi Indian Agriculture Scientist Award by Krishi Sevak Weekly for contribution to agriculture in the year 2021. Excellence in Research Award for contribution to post-harvest engineering and technology, as well as the Best Agricultural Scientist Award for contribution in the area of plant pathology during International Conference in Navsari in 2023. She has received commendation certificates and also of Indian Phytopathological Society and Best Paper Awards. She has published and presented widely. She has handled projects. She has guided master's and PhD students, and also published 2 books, 7 booklets, 17 folders, practical manuals, and 20 popular articles. Given 2 national level recommendations, 23 state level recommendations, and has also given several guest lectures. Recently, she has developed UV-assisted treatment device for Nagpur mandarins and sweet orange, and bulk production protocol for silver micro nanoparticles. As on date, she has overall 951 Google Scholar citations of her research publications, with Google Scholar index of 11 and Google Scholar in out I10 index of 12. With that impressive information about her, I call upon Professor Ashwini Cherpe to talk. Ma'am, we give you 10 minutes and welcome you to the session. Over to Professor Cherpe.
Thanks a lot, Bini, for giving such a nice introduction. And I would like to appreciate actually Dr. Ghosh for a comprehensive lecture that he has given. Definitely, we are very having a very rich indigenous knowledge available to us. Indigenous technologies have been a backbone to the economy of Indian history. But I would like to take the scientific temper and indigenous technology, this topic, towards the indigenous technologies developed in the current era, so that we can really achieve Viksit Bharat in the year 2047. That is a national target. And for that, actually, I would like to, there was a very good observation by him regarding the Brihadeshwar temple. I would like to add a few points to it. Not just lifting the this top to means to high level, it is placed at such a location on the means such a location that it doesn't create any shade around it. That is very, very means unique about the Brihadeshwar temple. And here I'm having few slides that I'd like to show you.
You may go to the fifth icon which says present now and then select your slide.
Yeah. Okay, is it visible now?
No, not yet. Please keep the slide open. After that, go to present now and select.
Okay.
Yes, we can see it now.
Is it visible there to everyone?
We can see. We can see it.
Okay.
But I think you have to actually. Yes, we can see it now. It's visible.
So, like we are discussing regarding the indigenous technologies, here I would like to highlight few of the technologies developed by our center and also in various institutes of India. Those are current days indigenous technologies, and we can aspire for a brighter future for the country. Here, the main highlight is regarding post-harvest processing technologies. And these are the few machines you can see here. Uh, this one is a mini dal mill developed at Dr. Panjabrao Deshmukh Krishi Vidyapith Akola. Till date, we have been able to sell at least 7,000 units of this unit. A staff of former this machine is completely indigenous, developed by our own scientists, and it is a small scale dal milling plant which is available in 3 HP, 5 HP models, and also there is integrated mini dal mill. Many kinds of dals can be prepared from this machine, like pigeon pea, chickpea, then there is green gram, and also the urd bean. So many dals, and also not just splits, but also the polished ones can be prepared. We can use the machine for cleaning of wheat and its grading as well. This so many dal milling units, same like the atta mills, dal mills have been installed in various villages by farmers, and it is very economical. Means in an investment of 150 to 2 lakhs, actually we can start a business, and the new rural youth, those are educated and can coordinate the thing with the market, are developing this is a choice of them in the areas where dals have been grown, especially pulses have been grown, and because it is multi-purpose, so many pulses can be processed out of it. Similarly, the second machine is regarding the cleaning and grading of the grains. The third one is polishing for the dal. This one is a besan mill plant, and whatever the byproducts of milling, means we get chuni, bhusi, etc. So those powders can also be utilized by mixing in certain proportions with a sticker material, and then passing through this machine to prepare a feed for animals. So likewise, this is a comprehensive, means only few of the machines I have shown right here, right now, for the processing of pulses. Those are indigenously built, and we can have a good business out of it. And already many units have been established in central India, and also this dal mill has been exported to some African countries as well. Now this is a second focus is regarding the processing of fruits. Like the processing of pulses, for fruits as well, we have developed certain machines. What I am projecting right now is a PKV UV assisted treatment device for oranges. This machine helps in application of waxes to the spherical fruits, and we have tested it and developed for oranges and Mosambik completely indigenously. This is my own work, and the benefit of using this machine is we are sterilizing fruits by using UV irradiation, so that there is no need of applying fungicides to the wax. Those are coated on the fruit, and therefore they are eco-friendly and healthy, and can fetch international market as well. So this is a very promising indigenous technology that can give a very good future. Many Santra processors from MP and Central India, Maharashtra, have approached us. There's one parallel testing going on by the JNKVV at Jabalpur. This is a university at Jabalpur, Jawaharlal Nehru Krishi Vishwavidyalaya. And also the Gujarat Agriculture University has found it useful. They wanted some little changes to it so that they can try it for chiku and the fruits of their areas, and citrus as well. So right now we have released it for oranges and sweet orange. And these are certain machines. Those are developed for making cherry or tutti frutti from the papaya, and as well as our pumpkin. And there is a machine for grading of fruits, another for extracting pulp from jamun, extracting pulp from custard apple. These are the products we can prepare: cherry or tutti frutti from papaya and pumpkin. And this one is normally we call it rabdi, or also ice cream is prepared with custard apple, for which we have developed a pulp extraction machine. These machines are related to processing of spices. The first one, this is a 20 tons per day capacity machine. The earlier one for Nagpur mandarins is also a commercial one of 20 tons per day capacity. The onion grading machine is has been tested at Lasalgaon, where the biggest mandi of onion is situated in India. And the second one is regarding extraction of seed of onion, because onion flowers are very chaffy and it is very difficult to separate the seeds out of it. So kalonji banane ke liye actually this machine is very useful, and also for the seed purpose. And this one is a turmeric washer. Turmeric is having a similar kind of rhizomes like gingers, and they are completely coated with soil when they are digged out, and it requires a thorough washing, 2 to 3 times washing to the before going for a processing of turmeric for the powder preparation. So we have developed a washing machine, turmeric washer, which removes complete adherent soil from the rhizomes. And another machine is for extraction of seeds from chili. And these seeds can be sold as the seeds for sowing purposes. And the flags are used for various market applications like preparation of chutneys, Szechuan chutneys, etc. And also our indigenous Varadi Thecha, in Marathi we call it Varadi Thecha, red chili means very spice with mixed with garlic, etc. So that is one indigenous product, very popular for centuries, can also be prepared from the flax after removing the seed. These are few examples of how entrepreneurship possibilities are there through these machines. I'm showing 3 agro-processing centers here. Those have been established at Hathroon, and then Kanzra, and also in Ahmednagar village, in village places as well as district places, where they have taken a group of some machineries. Those are suitable for the crop grown in their area. Our center is guiding them to select the machines as per the availability of raw material in their area. And all these machines are indigenously developed, and they are processing it and bringing it to market. And this is one example of the person working at Hathroon. He has prepared different dals, and these pulses have been packed. He has also taken a brand name for it, Dwarkai, and likewise we can go for branding of our products to complete indigenous technologies. And until and unless we don't rely on our technologies, we won't we can achieve the target uh, by 2047 of a Viksit Bharat. And our indigenous technologies developed in different centers are going to be of great help to our youth, educated ones and uneducated ones as well, and rural dwellers as well as the urban population. This is another example, the jamun, different jamun products, jamun juice, pulp. It is very, very useful for the diabetics and has very good market. So this kind of branding has also been done. And in this particular slide, I am showing the technologies developed by the national institutes in India. We are having a complete big framework of institutes, and Indian Council of Agriculture Research is harboring many institutes. Similarly, CSIR is harboring many institutes. Just to give few examples, here I am quoting the example of a solid adhesive developed from cassava roots by the CTCRI, Central Tuber Crop Research Institute, Thiruvananthapuram. And this glue is high, very sticky, and even ceramic tools, means ceramic surfaces can be glued using this one. And then they have also developed this sweet potato chips, which is also having a very good commercial value. And then there is a coconut sugar developed by CPCRI, Central Plantation Crop Research Institute. This is situated at Kasargod. They have developed a sugar from Nira, which is coconut juice, and they can develop chocolates. They have developed chocolates as well. So these technologies are there. They have developed in-house technologies developed in India. Similarly, one very promising technology developed by CIRCOT, ICR CIRCOT Mumbai. This is Central Institute for Research on Cotton. They have developed antimicrobial cotton bed sheets, and this cloth is useful. Means they have developed the yarn and clothing from the naturally colored cotton as well. And likewise, it is going to give a very good future market to these technologies. The only thing is our youth is supposed to be connected with these institutes. So we are supposed to be abreast now, like on this virtual platform we are interacting. There is immense possibility that they can explore the technologies available and developed by Indian institutes, and those technology they can directly contact the institute. Contact details are given on every institute is having its own website, and on that, in the technology section, these details are given, and by contacting them you can have a MOU with the institute and get the technology and can start entrepreneurship at your own. And not just that, you can also have your own ideas. And another few technologies that I would like to highlight is like making poha flakes. Uh, rice flake, poha is a rice flake, very well known to every one of us. Similarly, now IARI, Indian Agriculture Research Institute, situated at New Delhi, has developed flakes of pigeon pea, means tur dal, maize, and sorghum as well. And some fruit juice extraction machines everyone might have seen on small stalls and fruit juice centers. But for its commercial application, a big machine has been developed by Mahatma Phule Krishi Vidyapit, Rahuri, uh, which is useful for juice extraction, and a commercial plant can be developed. Similarly, ready to cook mixes and food are developed from pearl millet by Tamil Nadu Agriculture University, Coimbatore. There are many more such technologies available in India, and we can we should keep exploring the technologies available in our nearby institutes and in our zone. Whatever the crops or the byproducts are available in our area, we can take them, and mostly the institute situated in our own zone, like this platform is having many students, those might be coming from different states. So I would like to highlight them that there must be many institutes situated around the cities in their area, and those institutes are there because they have to work on the crops and raw material available in their zone itself. So from by contacting them, you can get the information regarding new technologies and can initiate good entrepreneurship possibilities there. And some indigenous businesses using indigenous technology can be developed, and whatever the examples I had given you regarding the Krishi Prakriya Udyog Kendra agro processing centers, they are having some earning of say 3 to 4 lakhs every year. The initial investment of 1.5 to 2 lakhs are recovered in within one season, and it can help our youth, uh, especially for the MP region, where is a big area is of pulses. There is a big area of fruits as well, and Andhra is having a good area of fruits. Andhra, Karnataka, in Punjab, Haryana also there are some cereal based businesses and fruits based businesses can be started. So right now, our youth is also becoming interested in uh, towards the entrepreneurship development, and also there are certain uh, government aids available right now in on our machineries what we are developing for agro processing. There is one prime minister scheme running on it, and up to 35% subsidy has been provided through that scheme to the entrepreneur, and there are loans available through Grameen banks and various funding agencies. And if self-help groups want to develop, they are getting all these benefits. So women's self-help groups have been supported a lot, and definitely we can have a better future if we go for certain technologies. Not just I have shown you the examples of the processing, agriculture processing related technologies, but there are many other technologies, and ideas of your own will be helpful in developing new businesses. And I would like to That means I want to greet Dr. Bini and his team that they have taken this topic when it is imperative for India to look forward towards a direction where we can be self-reliant and in future we can lead the globe. So with these words, it's over to you, Madam Bini.
Thank you, Professor, for a wonderful presentation, for hearing from a very passionate researcher. Thank you for sharing your own research and also the research of various indigenous technologies of other institutions. And then thank you for the journey in which you took us from research to the practical utilities of these machines, and also sharing the various possibilities for entrepreneurship by the use of these indigenous technologies, while we are dreaming of Viksit Bharat in the near future. Thank you, Professor Ashwini, for your wonderful presentation, and it was good to hear you after a long time. Thank you. And now it will be a pleasure to listen to Dr. O.P. Sharma. And, at IGNOU, we have been talking of innovation and entrepreneurship. Entrepreneurship, new ideas, innovation, that is where Dr. Ashwini has left us with her talk, and now we carry it forward from there. Today we are with 26 crores students in schools and 4.1 crore students in higher education. We have a workforce who have to be transformed, in whom we have to instill the ideas of critical thinking, creativity, innovation, solving skills, decision making skills, communication skills, and inculcating of scientific temper. As educational institutions, it is our responsibility to shape these young students so that they become more innovative and develop their entrepreneurial skills. With these words and introduction of Dr. O.P. Sharma, inviting him for his presentation. Dr. Om Prakash Sharma is presently working as the director of the National Center for Innovations in Distance Education and posted at IGNOU in New Delhi. He is a physicist and MA in distance education. At NCIED, he is working towards finding innovative and technology-enabled learner support and solutions for the distance learners using newer technologies. He is actively involved in promoting the culture of innovation among the students and faculty of the university. He has designed and developed several innovative schemes like on-demand examination, digital question bank, science at mobile, Shodhara, and so on in the university. His areas of interest are science popularization, technology-enabled teaching learning, research in open and distance education, examination reforms, and so on. He has rich experience of more than 24 years, not only in the open and distance learning system, but also in the areas of research. He has also worked at NCERT and with the Planning Commission of India. With these brief words and with this brief introduction, I invite Dr. Om Prakash Sharma to talk about innovation and entrepreneurship while we discuss the broad topic of scientific temper and indigenous technologies towards the Viksit Bharat. Over to Dr. Sharma.
Thank you, Dr. Vinnie Toms. Good afternoon to all of you. Today we are talking about the National Science Day, and then my fellow panelist, Dr. C.K. Ghosh, has talked about the scientific temperament. He has highlighted the basic objective of celebrating to this day was basically to develop a scientific temperament, scientific attitude among the people. They should be able to think about the science, talk about the science, and then accordingly think of some new and innovative ideas. Professor Ashwini Charpe has talked about the entrepreneurship and indigenous technology. In fact, when we talk about the Viksit Bharat, both these two aspects are very important. If we talk about the innovation entrepreneurship and not having scientific mind, innovative mindset, then it will be very difficult to talk about that. To achieve that Vikasit Bharat, it is very important to have scientific temperament, to think of science, to talk about science, and also think of the problems around us. Because unless we identify the problems, what are the need of the society, what are the requirement of the country, individual peoples, then I think we may not be achieve that objective of Vikasit Bharat at 2047. Both these two aspects are very important. Having scientific temperament and also having an innovative mindset towards entrepreneurship and startup. Whatever indigenous technologies Professor Ashwini has talked about, basically I would like to connect them with the innovation, because anybody who has developed, who has designed these devices, technologies, they must have thought of the problems around them, problems of the society or need of the people. Say she talked about that orange segregation kind of a machine, orange related something. So what was the need of that? Someone might have felt that yes, there is a need of this kind of device, this kind of system that one should think. Accordingly, they thought of some idea, innovative solution, and then came out with that device. So I would like to emphasize that there is a very strong connection between these two things, scientific method and innovation life cycle. In scientific method, because today we are talking about the National Science Day, and when we talk about the scientific temperament, in that context, method of science is very important. And in fact, we all knowingly or unknowingly are following that method of science in our life. In that, there are certain steps, certain stages that I would like to highlight. First one is very important, that is to be a keen observer or to question the things what they are observing. Why it is happening, what is this, what, why, and how kind of things they'll have to question. Anything they are encountering, first thing is to observe that. When we observe certain thing and then we, based on that observation, we take some kind of a idea is generated in your mind, or we can say some problem is identified or some need is identified. And I would like to say that when we talk about the innovation, then also when we talk about innovation, first thing is what is the need of the people, what are the problems of the society. So these two things are very much connected with each other. So the National Science Day today being celebrated all over the country, in fact all over the world, that gives a very clear-cut message. We should think differently, we should think innovatively, considering that scientific attitude in mind. When we are having that scientific attitude in mind and we trying to find the solution accordingly as per the need of the society, of the people, or even the individual, then I think we can think of converting that idea into a proper entrepreneurship. In scientific method, after that ideation, the next thing is to test it. But in case of innovation, next thing comes the prototyping of that. In fact, in science also, many times different kind of models are created, different kind of other testing devices are created. Similarly, in case of innovation also, based on that idea, whatever idea came to our mind, we generate or we produce a prototype. And then after that prototype, we try to test it in the particular situation. When we talk about the scientific method, then also whatever idea, whatever solution is coming to your mind, we try to experiment it, test it, and then conclude based on that what is the next thing. So these are the two parallel things, were very much connected with each other. And if we integrate both things, then come out for a innovative solution, then I think we can think of developing a very useful, innovative device, service, or system which can be easily converted into a an entrepreneur or a startup, or can lead to developing an indigenous technology. Fortunately, today in our country, Government of India is emphasizing on developing this kind of startup and innovations. A very strong innovation and startup ecosystem is there in place in the country, supported by the Ministry of Education. In fact, Ministry of Education and other ministries, they have taken other ministries together. Whatever different kind of schemes are there, they are trying to support and fund the innovator students so that they could take their idea to a proper, viable, commercializable startup. This is a kind of a system that is now happening. Based on that, I would like to emphasize that the Indira Gandhi National Open University is also taking similar kind of steps. What we are doing here in the university, because we have a very large number of students with us, together with a very large number of alumni, we are trying to first motivate them towards innovation and startup. And this kind of motivation and startup that we are doing with the help of different kind of activities that IGNOU is organizing, and this is one of the similar kind of activities that Regional Center Bhopal is organizing. The basic purpose of today's activity is basically to encourage and motivate our students towards innovation, startup, and scientific attitude. I think similar kind of many activities are being organized by this regional center and other regional centers also. So that is creating a culture of innovation and startup in the university. So when we talk about the scientific temper, that leads to an innovative mindset, and then innovative ideas are generated, and then startups or entrepreneurs are being created. So this way, the university is trying to create a culture of innovation, and then we are trying to identify the potential innovator or startups also. Many examples Professor Ashwini has given. Our students are also doing similar kind of innovative product development, innovative services development in different sectors. In fact, in case of agriculture also, a number of such kind of devices, services have been developed. And for that purpose, we are trying to identify also those students through different kind of activities like idea competition, innovation award competition, startup competitions. And then these students, all these students and alumni, they are being guided, mentored in one-to-one way. So from those ideas, they are able to take those ideas to the next level and converting them into proper startups. So, and next thing in that context is the networking of the students. IGNOU, through its regional centers, is trying to network the students, innovator students, startups also, along with the mentors, experts from different academia, from industry, and that is helping in creating a culture of innovation and a kind of innovation and startup ecosystem. And that ecosystem is helping our students to develop this kind of indigenous technologies. And students are coming up with very innovative ideas, and they are finding the solution to the problems of the society, problems of the country in different sectors, maybe health sector, maybe food and agriculture, rural development, and environment, etc. And these students, they are now coming up with the national events also. They are participating in different national events, and these all are trying to contribute towards the Vikasit Bharat. In fact, if we talk about the goal of the Vikasit Bharat simply emphasizes on 4 areas. One is the empowering the youth. Whatever activities IGNOU is organizing, those activities are trying to empower the youth to think differently, to think scientifically, and develop something innovative to the country and to the society. Next very important goal of the Vikasit Bharat that Government of India is visualizing is the community development. Community development also, whatever contribution is IGNOU students and alumni are doing, they are basically in a indirect or indirect way helping the community. And also our regional centers, and we at the National Center for Innovation and Distance Education, we are trying to engage the community also in these all processes, because whatever we are doing, we think the community should be involved in those all events, so that their participation is also ensured. Next important focus of the Vikasit Bharat at 2047, that is to empower the youth towards innovation and entrepreneurship. Innovation and entrepreneurship clubbed with the scientific temperament, when we talk about the National Science Day, that can certainly help in achieving the goal of the Vikasit Bharat at 2047. And another fourth goal of the Vikasit Bharat, that is a civic engagement and improvement in the governance. Civic engagement is very important, and I would like to emphasize a number of activities at the regional center and the headquarters. They are primarily focusing on engaging the students in different kind of activities where they can basically ensure to follow their duties in addition to their rights. Because when we talk about the duties mentioned in the constitution, that can lead to the civic engagement, maybe the swachhata, maybe the caring for the public property, maybe for any other thing. So that kind of these four goals which have been emphasized in the Vikasit Bharat at 2047 are being taken care by different constituents of the university. And today, when we talk about the scientific temper and indigenous technologies, these all things, I think they come together, and then if they are integrated together, then I think we can achieve the goal of Vikasit Bharat in 2047 very easily. And I think it will be good to involve all our alumni and IGNOU students also for that purpose. Many are coming already participating, and this kind of program, they will encourage other students for that purpose, and we will be able to achieve the goal of Vikasit Bharat in 2047. Thank you very much.
Thank you, Dr. Sharma, for a very brief and crisp presentation. You're right, sir, that at IGNOU, we have been able to create a culture of innovation and along with that, an ecosystem of innovation and startups. And this has been possible because of the consistent efforts by Team NCIED, spearheaded by Dr. Om Prakash Sharma. Because whatever the tight schedules of the university, they make it a point that these activities of innovation, entrepreneurship, and involvement of students keep going on regularly. Sometimes it becomes very difficult for us to adjust and fit into the NCIED activities, but because you have made it in such a way that we cannot be left out, whatever the busyness of schedules, the admissions or the examinations, but this also has become a part of our daily schedules. Just like examination or admissions and counseling and so on, innovation and entrepreneurship and the idea of creating a whole ecosystem, an ecosystem of innovation that has come into our minds now and also into the minds of our students, thanks to the team NCIED and your consistent efforts. Thank you, Dr. Sharma. So I think with these presentations, now we have people who have raised hands. But before that, let me take one or two questions which I have noted down to people who have written to me. And then we take Kunal Ambasta has raised his hand. He is one of our innovator students. And before that, let me, I have a question for Dr. Ghosh. This is a kind of question that comes up every time, but it is always good to hear an answer from Dr. Ghosh. So the question is, how convinced are you of observing one day in a year as Science Day? This is a kind of question that comes up every time. So of observing one day as Science Day in a year.
No, if it comes to the theme which you said, scientific temper, it's an everyday affair. But we have to observe something, like any person, say he is always important, but we observe something special on his birthday. So this is a kind of a custom, a kind of a tradition. Definitely one day is not sufficient. It is an everyday affair, but it's a part of the custom, so that we are reminded. There are so many other things which are also important. So in order to give space to everything, one day is allocated for science, but it does not mean that one has to do science on only that particular day.
Yes, sir. Thanks. So that's a very convincing answer. And I think you're right about that. So there is another question, which is again directed to you. How to talk the language of science with students on a daily basis?
Yeah, that is very simple. In fact, you try to connect science with life. You try to connect science with life. See, I'm giving a very simple example. In fact, the other day I was going to the market. I was asked to bring some corns. Now, how much? Now, this much. Now, this has been the tendency of many people. In fact, they are very much averse to measurement. So, every day you can tell the students about some measurement or the other. I had been to a school when IGNOU was in the process of launching its diploma program, DPE, Diploma Program in Education, and it was in collaboration with NCERT, and it was quite a coveted program. It created a lot of hype. First, it was launched in Gangtok, and I was there when the director, NCERT, and our vice chancellor together, they had declared the launching of this program. So when I was going to different schools, primary schools, for checking the infrastructure, as you know that IGNOU has to depend on their infrastructure for opening study centers or work centers or whatever. And in a particular school, the mathematics teacher was teaching plus fourth standard students. So I asked the teacher, what is the topic? He said that measurement of length by metric system. So I asked the teacher, what is the state of preparation? Because he said that tomorrow there is going to be a revision test. He said that they are all prepared. So I asked them, what is the relation between a meter and a kilometer? Everybody answered perfectly. 1,000 meter equal to 1 kilometer, or 100 centimeter is equal to 1 meter, and so on. And then the students were located in a village a little far. The school was a little far from their house. And so I was prompted to ask that, how far is your home from the school? Now no hands are getting raised up. What is the length of the classroom? No hands are getting raised up. How many centimeters is my pen? No hands are getting raised up. So, see, in fact, according to the teacher, they have learned everything about measurement of length by metric system, but they can't answer these questions. So, measurement is a very important aspect of science. When we say that the cricket pitch is 22 yards, have any one of us bothered to actually measure the 22 yards? If I take a tape and try to measure, we'll find it maybe 1 or 2 inch more. Still, this cricket pitch is measured in the foot-pound system. So it would turn out to be, say, 1 inch more or 1 inch less. So it just occurred to me. I asked the student in a classroom that what is the heaviest object in the classroom. You can see so many objects around. So somebody said that the blackboard, the desk, and so on and so forth. And then I asked them to work out the volume of the classroom, length, breadth into height. And then I asked them to multiply that with the density of air. And air turned out to be the heaviest object in the classroom. So these are certain examples which I wanted to cite, with which you can excite. Like today is 28th February. Of course, this is a part of mathematics. We remember it as National Science Day. As a matter of fact, I'm digressing a bit. This day also happens to be the birthday of a very, very famous Nobel laureate, Linus Pauling. He was born on 28th of February 1901, and he received 2 Nobel Prizes, one for chemistry and one for peace. And more important than that is the number 28. It is the second perfect number. The first perfect number is 6. A number is called a perfect number if it is the sum of all its factors including 1. 6 is 1 plus 2 plus 3, and 1, 2, and 3 are all factors of 6. The second perfect number is 28. 28 is equal to 1 plus 2 plus 4 plus 7 plus 14. So these are the things by way of which you can excite the student by seeing things which are around, you can connect with games like we have the champion Neeraj Chopra. So everything of physics of projectile motion you can tell by taking Neeraj Chopra's example. So many problems can, in fact, we have got two individual gold medalists in Olympics. One is Neeraj Chopra and another is Abhinav Bindra. So shooting of a rifle, a lot of physics can be taught. So you try to relate it with regular events which happen throughout the life, throughout the day. You ask the student to ponder upon how much you have depended on science till you got up in the morning and came up to the school. These sort of things you can excite the student about science. You connect it with the daily life.
Yes, sir, very rightly said. Connecting it with life, that is the key. Thanks for that response. One question to Dr. Ashwini, and then I will request Kunal to unmute himself and ask. Dr. Ashwini, there is a comment first that thanks for the elaborate information about processing technology, especially orange and cherry that you mentioned. That was an interesting technology. As a student, I would like to know that if we use any of these technologies for a startup, how would we know that it would make good business? Can you guide the student with any clues regarding his query? Please unmute yourself, Dr. Ashwini. You're muted.
Not just this question, also there is one question regarding how the scientific research includes social sciences. So one or two students have also wanted to have a relevance between a scientific temper and a social science. So I would like to tell them that our social preferences and our social behavior, it is the basis of invention actually. When we feel requirement for certain things, then only we go for innovating certain new technologies. And the study of social behavior of a given area can help you to support your startup or entrepreneurship business. If we understand the need of that area, then we can have a economically, means technically feasible and economically viable business. So with respect to startups and new enterprises, I would like to highlight first study the social requirement of a zone. For example, I would like to give you a very common example of khakra business or papad business that has initiated with, it was our daily requirement of a zone in Gujarat, and now it became very popular. Similarly, there is idli. Idli was first restricted, idli or other South Indian food, they were first restricted to southern India only, but now they have become global. So the need, understanding the requirement of the society helps us develop a economically viable business. Over to you, ma'am.
Right. So once they set up a business, I think there was a second part, that is there any factor by way of which they can know that this business is going to actually work?
Yeah, for starting any business, actually, we have to do some groundwork first. We cannot just come up with a certain idea out of your mind and in 1 or 2 months you will have a business. No, it is not. It is a long process of first understanding. Means not just having unique idea is enough. You have to understand all the technicalities related to you, related to the business, and your financial capabilities, how much you can invest in that business. Then you have to understand the area in which you are going to sell the product. So in how much you are going to invest and how much is there that you are going to earn. So there is a complete project we are supposed to write. There are formats available with different banks. Those are funding such businesses, and we have to understand those formats. We have to first assume that means all groundwork you have to do first. That how much I am going to invest, and for 1 rupee, how much I am going to earn out of it. So that is called actually the cost benefit ratio. We have to work out cost benefit ratio for each of our machines. We regularly work out this cost benefit ratio that by investing how much amount, and finally you will be getting what will be the earning. So connecting yourself well with the society, understanding the requirement of the society, having a unique idea, and the most importantly, every business should have a unique selling point. USP it is called. The terminology given to it is USP. If you have a unique selling point in your business, it is definitely going to succeed.
Thank you, Dr. Ashwini. I think that was a very well put answer, because all the queries around starting a business would have been solved for the students who asked the question, and also for the others who were hearing you. I think because when you said social requirement, that is actually important, and then doing the groundwork and actually understanding the whole situation and your capabilities before actually writing a project on starting a business. Thanks for that answer. And also thanks for answering Dr. Smriti, our colleague Smriti's answer about social science research. Thanks for answering that question too. Thank you, Dr. Ashwini. And now over to Kunal, our innovator student. Kunal, please unmute yourself and ask your question. Are you still there?
Okay. I think he's not there.
He's not there. Okay. While we wait for Kunal, maybe he'll join in some time. I have a question for Dr. O.P. Sharma. This is a very, I should say, this is not a very practical question, but this is something to be thought about. And I would request Dr. Ghosh and Dr. Ashwini also to answer this question. But first, over to Dr. Sharma. Does our academic curriculum, do you think that our academic curriculum promote science learning in its true sense?
In fact, not all courses, but it should be. It should be, because there are certain skills or scientific attitude kind of thing. They should be integrated with the programs and courses. But presently, I don't think, except science discipline program or environment discipline program, it is being considered, it is being taken care. I think Dr. Ghosh can elaborate on it.
Yes.
Because he has
yes. And Dr.
idea about the courses and programs offered by the university. But the National Education Policy 2020 certainly emphasizes on these certain kind of skills, particularly we can say 21st century skills, and which includes scientific attitude also. They should be encouraged through different kind of courses and programs, and for that purpose it should be I can say they made compulsory or integrated with all curricula.
Thank you, Dr. Sharma.
If we limit it to the science courses or discipline, then I think it will not serve the purpose. Because all students and all people should have these all scientific attitudes.
Yes. Thank you, Dr. Sharma. I think Dr. Ghosh partly answered the question during his presentation when he discussed in detail about the study of history, because he was mentioning that when we talk of history, the science students, they think that it is just learning or by hearting the dates and so on. But he said we should take that a step further in understanding the history and going ahead with that. So he actually answered that question in a way, but I would like him to take the question.
Can kindly repeat the question?
Do you think that today's academic curriculum promotes science learning in its true sense?
As I told, that questioning is the most important art in the journey of development of scientific temper. But questioning should have objectivity. Now, I consider this question as invalid because of its subjectivity. It is highly subjective because of the very adjective true. The word true has to be defined properly by the person who has raised this question. What is meant by true? Now, if that is clarified, then a proper answer can be given.
Yes.
So any question in science, like as Dr. Sharma was talking about development of skills. Now in learning science, we have to develop questioning skills also. In fact, it is not fair on the part of a teacher to discourage a student when he asks a question, but he should also encourage a student not to ask weird question. I'm not saying that this is a weird question. The questioner must be having something in mind about the word true, but that should be explained for the responder to facilitate his or her response. So, what is exactly meant by true here? I'd like to know in the true sense.
Mhm.
To me, true sense is development of scientific temper. And when you talk about curriculum, we have a tendency to use the word syllabus and curriculum interchangeably. They are different. Syllabus is the content. Whatever might be the content, that comprises the syllabus. And that added with the transaction strategy makes it the curriculum. So certain things which cannot be covered by the syllabus content or is not apparently covered by the syllabus content can be taken up by the transactional strategy, and that varies from teacher to teacher. It depends on how a teacher will take up that particular part of the content and then will make it scientific according to the need and demand of the student.
Thank you, Dr. Ghosh. Dr. Ashwini, would you like to take that question? Does our present academic curriculum promote science learning in its true sense? Would you like to answer that question?
Yeah, definitely. As far as our means area of agriculture is concerned, we keep on introducing the new developing topics to our course curriculum. The new curricula has been designed every certain period of time, and includes the practical aspects widely. Means our students have been given, like we are having exponential learning units in our universities. We are having a network of agriculture universities in India, and their experiential learning units have been developed where students get hands-on training of different technologies, operating different machines, and developing certain products. So likewise, I think our educational framework is promoting startups and entrepreneurship in country, and we are also having incubation center in our university, and there are many incubation center, and a complete network has been developed by the government and supported well. So in our university also we are having incubation center which is promoting startups and entrepreneurs. Our research unit, we are also supporting entrepreneurs. Whatever the examples of agro processing centers I have shown you, they were inspired by us. We reached to them, we identified their requirement, their financial capabilities, we helped them identify the funding sources, and likewise those businesses were established, and many of them have received state level awards as well.
Thank you, Dr. Ashwini, for sharing that information. Now, although we have many questions and queries, but I'll take one last question for Dr. O.P. Sharma before we close. Dr. Sharma, the question is, please guide us as to how an idea can be converted into a reality and a startup. Very briefly, because this is a question that can be explained in a very big session maybe. We need a complete session for that, but maybe you can take a minute to explain.
In fact, I was trying to compare the method of science and life cycle of innovation. In that, the very important thing is whenever idea is coming to your mind means you are addressing to certain problem, certain need of the society. After that, whatever innovative solution is coming to mind, you need to develop a prototype based on that. Prototype model may be something which you can say, yes, something whatever I have in mind that is a workable or doable kind of thing, that exercise you have to do. And when you develop that prototype, it need to be tested over a period, over a certain clientele for whom you are trying to serve. While developing that prototype, before that, in fact, it is also very essential to do a kind of a market survey. market research. That research helps in identifying the need of actual solution that you are going to do. Need of the people, or your competitors, who are the other competitors available there, whether actually there is a need of your another solution of similar kind of they are not. So that market research is required from different point of view, and also you need to think of what kind of capabilities, expertise, and resources you are having with you, because that also need to be assessed. Unless you assess those all things which you are having or which you can have, that I think is very important. And then after prototype development, it needs to be tested again. Go to do your prospective users or the consumers or whom we are addressing this thing, and then if their feedback or suggestions are there, improvise your product, and then think of commercializing it, then think of making it to the market. That is a kind of in a small words we can say that these are the different steps of a life cycle from idea to a proper innovative product development. And when you develop an innovative product and it is properly tested, then you should think of commercializing and enterprising it. That leads to startups or entrepreneurship also, because whatever innovative product or device or service you are developing, it should be at some stage commercialized. Otherwise, it has no use of in that way. These are the steps that need to be followed.
Thank you, Dr. Sharma, for very briefly presenting that important information. Dr. Ashwini, you've raised your hand.
Yeah, I just want to differentiate, means for students' information actually. There is little difference between startup and entrepreneurship. So to make them a little bit more clearer, startup is something that we start with having your own idea, a completely new idea that comes to your mind, and the process, the startup life cycle, what Dr. Sharma has explained, you have to go through that, work on that, means you have to research on that yourself and come up with a prototype, means initial model, which will solve the question raised to your mind. And then you see what means initially you identify a gap, a research gap, and that research gap, after identifying the gap and the requirement of the society, you develop a certain model, and then you go for registering it, patenting it, commercializing it, and likewise at the end the business development part comes. So that includes, startup includes your own idea, research on it, and then commercializing it. Whereas entrepreneurship means you can take any developed technology available with any of the institutes, and you can directly make a project and get funding from funding sources, and can initiate a business of your own. That doesn't involve much research. You can take a ready research as the examples I had given. Those can be taken by after doing memorandum of understanding, MOUs you are supposed to do with the university, and then there will be some percentage of royalty to be paid to the institutes, and means from your benefits, from the outcome of your businesses, from your benefits, say 2%, very nominal it is, and then you can use the technologies developed by them. For patented technologies, there are different legalities, and for non-patented ones, there is as such no legalities. You can directly go for MOU and start developing the products. Like our machines, we are doing MOUs with different fabricators. Means initially we conceive a new idea will come to us. We will see its need. They should be need based is the first requirement. Need based ideas are developed as projects. We get funding agency from the like from All India Coordinated Research Project, and after that the final developed machine that we are supposed to hand over to the either go for patenting or to the public domain. So if we are putting it in public domain, directly we go for MOU, and those agencies then develop different replicate it and sell it at their own in the market. So they are given the manufacturing rights. We share our designs with them. So that is a difference between means startup and entrepreneurship.
Thank you, Dr. Ashwini, for clearly bringing out the difference between the terms, startups and entrepreneurship, for the benefit of all participants present here. With that, we wind up this important panel discussion on the occasion of National Science Day, presented by the Indira Gandhi National Open University Regional Center, Bhopal, on the topic scientific temper, technological, indigenous technologies towards a Viksit Bharat at 2047. Our panelists were Dr. C.K. Ghosh, Dr. Ashwini Charpe, and Dr. Om Prakash Sharma. And if I conclude the discussion points, we started with what is scientific temper, how important is scientific temper when we talk of research, and also that scientific temper and science learning should be an everyday affair, and that is possible when we connect science with life. Then we went on to talk about indigenous technologies. We got examples of indigenous technologies developed by Dr. Ashwini's institute and other institutions, and then going ahead with how the possibilities of entrepreneurship by use of indigenous technologies when we talk of a Viksit Bharat. Later on, Dr. O.P. Sharma spoke in detail about the culture of innovation and entrepreneurship that needs to be created, and in fact not a culture but an ecosystem of entrepreneurship and innovation that needs to be created in educational institutions and the country at large, so that we move towards Viksit Bharat, which is an example in front of the whole world. So with these words, I wind up this discussion, and before that, I hand over the mic to my colleague, Dr. Anshuman Upadhyay, Deputy Director, to propose the formal vote of thanks. Over to Anshuman.
बहुत बहुत धन्यवाद मैम। आज के इस अवसर पर सबसे पहले क्षेत्रीय केंद्र भोपाल की ओर से मैं धन्यवाद देना चाहता हूं डॉक्टर चिन्मय कुमार घोष सर का, जिन्होंने आज सुबह इस पैनल चर्चा की दिशा एवं दशा तय की। हमें बहुत गर्व है कि सर उसी इंस्टीट्यूट से हैं, उन्होंने पीएचडी की जहां पर सीवी रमन साहब ने काम किया था, और ये हमारे लिए वाकई गर्व का विषय है कि उन्होंने जो बात बताया कि किस तरह से सीवी रमन साहब को बहुत कम समय में नोबेल प्राइज मिला और वो बहुत ही कॉन्फिडेंट थे। ये हमारे विद्यार्थी एवं टीचर्स के लिए रियली प्रेरणादायक होगा। सर आपने जो जो बातें कही, विशेष तौर से जो संविधान की बात की जो हमारे क्या साइंटिफिक टेम्पर की बात है, वो वाकई गर्व का इशू है और निश्चित तौर पर आपके वक्तव्य से सभी लोग लाभान्वित होंगे। सर आपका क्षेत्र केंद्र भोपाल की ओर से बहुत बहुत धन्यवाद और हृदय से आभार। मैं धन्यवाद देना चाहूंगा प्रोफेसर अश्विनी चरपे मैडम का, जिन्होंने बहुत सारे स्वदेशी प्रौद्योगिकी के माध्यम से दाल प्रोसेसिंग के लिए मशीनें बनाई हैं, उन्होंने दिखाया है और उन्होंने ये भी बताया कि किस तरह से इन मशीनों को अन्य राज्यों में, जहां पर जैसे गुजरात का एग्जाम्पल दिया, जहां पर चीकू होता, उस तरह से मॉडिफाई किया जा सकता है और किस तरीके से इन मशीनों के माध्यम से एंटरप्रेन्योरशिप और स्टार्टअप शुरू किया सकता है। हम सभी लोग अक्सर आइसक्रीम खाते हैं और मिल्क शेक पीते हैं, केक खाते हैं, उसमें एक टूटी फ्रूटी होता है, लेकिन वो कैसे बनता है और उससे भी क्या व्यापारिक दृष्टिकोण से उसका एंटरप्रेन्योरशिप कराया जा सकता है। मैडम आपने ये सारी चीजें बताई, आपका भी हृदय से धन्यवाद और आभार। हम धन्यवाद देना चाहते हैं एनसीईआरटी के निदेशक डॉक्टर ओम प्रकाश शर्मा सर का, जो सदैव ही इस तरह की गतिविधियों में हम लोग का मार्गदर्शन करते हैं और इग्नू जहां पर मैक्सिमम दूरस्थ शिक्षा के विद्यार्थी हैं और जो लोग अपनी जरूरतों के अनुसार नवाचार करते हैं, उसको प्रेरणा देते हैं, उसको मेंटोर करते हैं और हम सभी लोगों को लोकल स्तर पर भी सर प्रेरित करते हैं कि हम विद्यार्थियों को चिन्हित करें और उनकी मेंटोरशिप करें। सर आपका बहुत बहुत धन्यवाद कि आपने जो इनोवेशन साइकिल है उसको विस्तार से बताया और इस महत्व को भी बताया कि किस तरह से हमें विद्यार्थियों के बीच में जो विकसित भारत 2047 का लक्ष्य और उनके जो चारों लक्ष्यों को विस्तार से बताया और किस तरह से हम विद्यार्थियों के बीच में चिन्हित करके उन्हें नवाचार के लिए प्रेरित करें, इस पर भी आपने चर्चा की। सर, आपका बहुत बहुत धन्यवाद और हृदय से आभार। हम आभारी हैं अपने क्षेत्रीय निदेशक डॉक्टर विनी टॉम्स मैम का, जिनके कुशल दिशा निर्देशन में इस तरह के कार्यक्रम आयोजित होते हैं। मैम, आपका धन्यवाद। हम धन्यवाद देना चाहेंगे विभिन्न क्षेत्रीय केंद्रों से जुड़े, जैसे लखनऊ से जुड़े प्रोफेसर डॉक्टर अनिल कुमार मिश्रा सर, जो वरिष्ठ एडिशनल डायरेक्टर है, वरिष्ठ क्षेत्रीय निदेशक के पद पर है, एवं जम्मू से डॉक्टर संदीप गुप्ता, विशाखापट्टनम से डॉक्टर धर्मा राव, जयपुर से डॉक्टर ममता भाटिया एवं अन्य क्षेत्रीय केंद्रों से जुड़े हुए सभी अकादमिक का धन्यवाद और हृदय से आभार। हम आभार व्यक्त करना चाहते हैं अपने सभी काउंसलर्स का, प्रोग्राम इंचार्ज का, कोऑर्डिनेटर्स का, जो इस कार्यक्रम में जुड़े और इस चर्चा को सफल बनाया। मैं आभार व्यक्त करना चाहूंगा अपने साथी डॉक्टर सुभाष रंजन नायक, डॉक्टर कुमुद वर्मा मैम, डॉक्टर स्मृति गार्गो, डॉक्टर मिस्टर चंद्रप्रकाश मोरसिनिया और श्री आशीष कुमार जी का, जिनके सहयोग से इस तरह का सफल आयोजन संभव हो सका। एक बार पुनः सबको राष्ट्रीय विज्ञान दिवस की अत्यंत शुभकामनाएं और हार्दिक बधाइयां। नमस्कार।